Hi, today we are looking at section 7.8, which is solving problems with exponents and logarithms. So we'll be looking at some real world formulas and utilizing what we have learned so far in this chapter to help solve for various parts of formulas. So most questions will be about investments or Richter scale or pH scale. So for problems about future values, we use the equation FV is equal to R bracket bracket 1 plus I bracket to the power of n minus 1 over I, where FV is a future value. So how much you will end up with. R is regular payments that you're making. So this is for an investment. So you're putting in regular payments, where R is how many dollars that you're putting in regularly. Then I is our interest rate per compounding period as a decimal. N is our number of investments. And then I, once again, is our interest rate per compounding period as a decimal. So for example, determine how many monthly investments of $200 into an account that pays 6% annually, compounded monthly, for the future value to be 100,000. So I would probably start by writing out what information we have. We've got future value is 100,000. We have regular payments of 200. And we have an interest rate that it's 6%, so it's 0.06. It's compounded monthly, so we need to divide that by 12. So that gives us an I of 0.005. So now we'll write out our formula, fill in what information we have so far. So we've got future value is equal to our regular payments times 1 plus our interest rate per compounding period to our exponent of how many times we put in $100, or sorry, our regular payment, our $200, minus 1 over our interest rate. So we'll start by filling in our information. So we've got 100,000 equals 200 times 1 plus 0.005 to the power of n minus 1 over 0.005. Now, the first thing I would do is get rid of this fraction by multiplying both sides by 0.005. So that gives us 500 is equal to 200 times 1. Might as well add these together. So 1.005 to the power of n minus 1. Next step, I would divide both sides by this 200. So that gives us 2.5 is equal to, we can now drop this out of bracket, so 1.005 to the power of n minus 1. At this stage, I would add 1 to both sides. So we have 3.5 is equal to 1.005 to the power of n. At this point, I would change this into a logarithmic function. So we'll change from exponential to logarithmic. So if we change into logarithmic, this would be our base. So we've got log base 1.005 of 3.5 equals n. we can break that into two separate logarithms. So that's log of 3.5 divided by log of 1.005 gives us our n. And that gives us 251 payments. So in roughly 20 years. To figure out loan payments, we have a similar formula, except for we've got PV, which is present value, so how much you owe. Or we can also have it represent how much money we have as a lump sum that we're withdrawing money from. R is once again our regular payment, or how much money we're withdrawing. I is our interest rate per compounding period as a decimal, and our N is number of payments or withdrawals. So example, person borrows $15,000 and they pay back $300 per month. If annual interest rate is 6% and is compounded monthly, how many payments will they make? And what will they pay in total? So just like the last one, I would start by writing out what information we have. We've got present value is 15,000. Our R is 300. Our I is 0.06 divided by 12. So that's going to be 0.005. And we want to solve for N. Now we'll start by writing out our formula. So we've got present value is equal to our payments times 1 plus our interest rate per compounding period. Oops, sorry. I started writing out for one for a future value. So our present value is R times 1 minus 1 plus our interest rate per compounding period to a power of negative of our amount of times it compounds, or how many payments we make. Both those numbers should be the same, divided by our interest rate per compounding period. So we'll fill in what information we have. We have 15,000 is equal to 300 times 1 minus 1 plus 0.005 to negative N over 0.005. Now, just like the last one, first thing I would do is get rid of this fraction. So we'll multiply both sides by 0.005. So that gives us 75 is equal to 300 times 1 minus 1.005 to the power of negative N. Our next step, I would divide both sides by 300. So that gives us 0.25 is equal to 1 minus 1.005 to the power of negative N. At this point, I'd move for 1 to the upper side. So that gives us negative 0.75 is equal to negative of 1.005 to the negative N. Now, before changing to logarithms, we probably want to get rid of these negatives in front, so we'd multiply both sides by -1. So that makes us positive 0.75 is equal to 1.005 divided negative n. Now we'll change this into a logarithm. So we'd have log of this base. So log of 1.005 of 0.75 is equal to negative n. We can split that into two separate logarithms. So that'd be log of 0.75 divided by log of 1.005 equals negative n. Now that gives us negative 57.68 or 57.7 equals negative n. Multiply both sides by -1. So we've got 57.7 payments. Now, if we want to know how much we paid total, we were paying $300 a month. So what we can do is take our 57.7 and multiply it by our $300. And we find out that on the loan of $15,000, we ended up paying back $17,310.